In this figure, we are required to find the area of the circle. So inside the circle, we have 4 squares inside it, each with area of 4 units. So, and this is the center of the circle O. So with that information, what is the area of the circle? So points A, B, and C are points of tangency. As you can see, these are squares where each has an area of 4. And we know that area of a square is equals to side squared. Okay? And we are given the area for each, which is 4. So 4 is equals to side squared. Make S the subject. We get the square root on both sides. So this cancels with the square root. So S, or side of the square, will be equals to square root of 4 is 2. So the side of the square is equals to 2. So each side length is 2. This side from here to here is 2. From here to here is 2. Also from here to here is 2. And from here to here is 2. All the sides of each of the squares is 2 units. Now, since O is the center of this circle, let's draw a perpendicular line from this point O to this line BC. As you can see, I've drawn a perpendicular, so this is 90 degrees. Let me call this point E. Also, let's draw another line to connect center O to point C. Just like this. So OC, as you notice, OC is the radius of this circle. So this is radius R. This line OC is radius. Now, we know that from chord of a circle theorem, if you have a chord, and this is the center, and it cuts through, the radius cuts through that chord, then the radius or diameter, which is perpendicular to a chord, it divides it into 2 equal parts. Therefore, this part from here to here is equals to from here to here, implying that since now this is, if we are to extend it up to the circumference, it will be a radius. That implies that BE is equals to EC from chord of circle theorem. This implies that we already know that BC, which is the side of the square, is 2. So therefore BE will be 1 and AC will also be 1. Since each side of the square is 2 units, so from here to here is 2. Also from here to here is 2. But then from this point up to the center of the circle, we don't know. So let's call it X. Okay? So only this part from here to here is X, while from here to here is 2 and from here to here is 2. Therefore, OE will be equals to X plus 2 plus 2. Therefore, OE will be equals to X plus 4. We already know that EC is 1 and OC is the radius R. So now this, since OEC is a right angled triangle, we can now use Pythagoras theorem to solve. Therefore, in triangle OEC, using Pythagoras, a squared plus b squared is equals to c squared, and our a is 1, so 1 squared plus our b is, we've got it is OE, which is x plus 4. So x plus 4 squared is equals to our c, which is r, so r squared. But from a plus b all squared being equals to a squared plus 2ab plus b squared, so we're going to expand this in this format here. So we shall have 1 squared is just 1 plus, when you expand this in this form, we shall have x squared plus 8x plus 16. This is equals to r squared. So let's make r squared the subject. Therefore, r squared will be equals to, let's start with x squared plus 8x, then plus 16 plus 1 is 17. So let's call this equation 1. Next is let's connect point O to A. Just like this. Also, let us connect A up to some point that we are terming D, such that when you get DO, you should be able to get that line DO should be perpendicular to line AD. Hope you get what I mean. Let me first draw it and you see. So this is what I was meaning. So I've drawn a line A up to a point. This point we are calling it D, such that DO is perpendicular to AD. So this is 90 degrees. Now, as you can see, AO is the radius of the circle. So this is R. And also, you can see that from here to here is equal to from B to E. So BE is 1. Therefore, from this point to this point is 1. And we know that from D up to this point is the side of the square, which is 2. Okay? Therefore, this implies that DO is equals to 2 plus 1, which is equals to 3. So from here to here is 3 units. Now, if we had this part here from here up to a point where it's equal, or when it's a full square, just like the rest, then from here to here would be 2. But since it's not a full side, which is 2, as you can see, it's just partly less than 2. So we already know that from this point to this point is x, and from this point to this point is 2, implying that from here to here will be equals to the whole, which is 2, minus the balance, which we don't have on this one, which is x. So from this point to this point will be 2 minus x. Hope we are together. Therefore, this implies that AD is equals to, since from here to here is a full square, from here to here is 2, so AD is equals to 2 plus 2 minus x, which is equals to 2 plus 2 is 4, so 4 minus x. Therefore, AD is 4 minus x. Now, considering triangle ADO, since we can see that it's a right triangle, we can use Pythagoras theorem as well. So a squared plus b squared is equals to c squared. Our a is DO, which is 3. So 3 squared plus our b is 4 minus x. So 4 minus x squared is equals to our c, which is the radius, r. So r squared. Again, from a minus b squared being equals to a squared minus 2ab plus b squared. This means that when you expand this, so 3 squared is 9. So 9 plus, when you expand this in this form, we shall have 16 minus 8x plus x squared being equals to r squared. Making r squared the subject, we shall have x squared minus 8x plus, so 9 plus 16 is 25. So let this be our equation 2. So now we're going to compare equation 1 and equation 2, since both of them are equations of r squared. Okay? So Since they're both for r squared, we're going to equate equation 1 and equation 2. So r squared is equal from r squared from equation 1 is equals to x squared plus 8x plus 17 is equals to r squared for equation 2 is x squared minus 8x plus 25. Now, as you can see, if x squared is to cross, they cancel. So we are left with 8x plus 17 being equals to negative 8x plus 25. Let's collect like terms. So we shall have 8x plus 8x being equals to 25 minus 17. 8 plus 8 gives us 16. So 16x is equals to 25 minus 17 gives us 8. So divide both sides by 16. And we shall have x being equals to a half. Now our next step is we're going to substitute for x in equation 2, which is this one here. Where there is x, we're going to put a half. So in equation 2, r squared is equals to x squared minus 8x plus 25. Therefore, r squared will be equals to a half squared minus 8 into a half plus 25. So r squared is equals to, this is 1 squared, which is 1 over 2 squared, which is 4, minus, this reduces, 2 goes into 8 4 times, so 4 times 1 is 4, then plus 25. Therefore, this gives us r squared being equals to a quarter plus minus 4 plus 25 gives us 21. Therefore, r squared is equals to, the LCM is 4. 4 by 4 is 1. 1 times 1 is 1 plus 4 by 1 is 4. 4 times 21 is 84. So r squared will be equals to, this plus this gives us 85 over 4. So now let's find the square root on both sides. Square root here, square root here. This cancels. And therefore r is equals to root of 85 over square root of 4 is 2. Now that we have the value of the radius of the circle, we can now find its area. So we know that area of a circle is given by pi r squared. Therefore, area is equals to pi. We've got our radius as root 85 over 2. This is squared. So we have area being equals to pi root 85 squared over 2 squared. So this cancels with a square root, and therefore area is equals to pi times 85 over 2 squared is 4. So pi times this gives us area as 85 pi over 4. This is in square units. You can go ahead and give it in decimal form if you wish. But this is the answer to this question. Thank you so much for watching. Kindly subscribe to this channel for more amazing videos. Like, comment, and share your thoughts about the video. And you can share this video with your friends also, so that they also benefit from it. Thank you so much. Please subscribe. It's completely free of charge. Thank you so much to those who have subscribed. Let's meet in the next video.